ELECTROCHEMICAL Revision Channel. Teacher Chinese Marita, Reverse Process School. Follow my channel, subscribe, click the notification bell to get notified once I upload a new video. Today we are looking at Kcse revision, a very important topic in Form 4, and that is electrochemistry. And today we are looking at the electrochemical cell. So I have a diagram, I have a representation of this electrochemical cell. So suppose now we have in an examination you will be getting something like this one, that is that directed potential given below, and then you answer the question which follows. So these are the half cells. So we have N, we have J, we have K, then we have J, and then we have M. Then we have the electropotential, standard electropotential. N is negative 2.92. Then K is positive 0.52. G is positive, K is 0.00, and then G is 0.08 positive, and then M is negative 0.44. From this electrochemical cell, there are some important things that you need to understand. One, you need to understand on how to write an ionic equation from the given two half cells. Identify the half cells that will give the highest potential, standard potential difference when combined. Identify the cells, the two half cells when combined will give the lowest potential difference. You will be able to draw the electrochemical cell or given the two cells and writing the cell notation. And also in that case, you are also supposed to know how to calculate the E and F of the cell. Apart from that one, in this case also you need to know whether a reaction will occur between the two cells or the reaction will not occur. In that case, you need to understand the principles of calculating the electrochemical, the standard electropotential, that is the E and F of the cell. So if the overall E and F of the cell is negative, it means the reaction will not occur. If the E and F of the cell is positive, it means the reaction will occur. That means now a certain solution will not be stored in a certain container. Those are some of the things that you should be able to understand when you are dealing with these questions on the electrochemical cell. So in the first case, you have a number line. I know most of you know how you can calculate the EMF of the cell, but on my case, I have just simplified using a number line. In mathematics, in Form 1, you are shown how to use the number line, and here now today I am introducing this number line on how to solve some of the questions in electrochemistry, that is an electrochemical cell. So the number line, you represent all these values you have here, negative 2.92, positive 0.52, 0.00, positive 0.80, negative 0.44. Represent these values on the number line as you can see on the screen. So I have represented these numbers on the number line. We have half cells of N, which is negative 2.92. Towards the positive side, we have negative 0.44. And then we have negative 2.92. Then after 0.00, we have positive 0.52, and then we have positive 0.80. So understand the number line very well. The far end towards the negative, it will give the strongest reducing agent. Get this one well. When you are using this number line, the far end, the half cells which is at the far end of towards the negative, it gives the strongest reducing agent. Then the far end to the positive, it will give the strongest oxidizing agent. So once you will be asked, identify the strongest reducing agent or identify the strongest oxidizing agent, always use the number. That at this far end here will give you the strongest oxidizing agent, and then the far end to the negative will give you the strongest reducing agent. In our case here now, the strongest reducing agent here, and then we have the strongest oxidizing agent. As you can see on this, from this number right here, I have said so G is it is the most positive, and therefore it is the far end towards the positive, and that one now gives the strongest oxidizing agent. So the strongest reducing agent is at the far end with the negative, and that one is negative 2.92, and that one now will give element N. How do you get this equation in an exam? You will be asked, for instance, identify the strongest oxidizing agent. Give a reason for your answer. So you just say that G is the strongest reducing agent because it has the highest positive potential difference. Or you can just say it is the most positive. So you just say it is the most positive, or it has the highest positive electrode potential. Identify the strongest reducing agent. That basically you will identify that one as an element N. The reason is it has the highest negative electrode potential, or you can just say it is the most negative. So we can also say this one here is the most. This one is the most. It is the most negative. So the most negative is the strongest reducing agent, and the most positive is the strongest oxidizing agent. Then I have indicated we have the elements that you can combine to give the strongest, to give the highest EMF of the cell. For example, you can combine the strongest oxidizing agent and the strongest reducing agent. When the two are combined, they give the highest potential difference. So the strongest oxidizing agent and the strongest reducing agent produce the highest potential difference when combined. So when you ask you to identify two elements or two half cells to combine to give the highest EMF, identify the most positive and the most negative. When you combine those two, they will give the highest potential difference of the cell. Another situation is where you will now be taught to draw the electrochemical cell that you have identified. In that case now, you have identified the strongest reducing and the strongest oxidizing, and therefore you are required to draw the electrochemical cell of the two half cells that you have identified. What will you do in that case here? You need to understand that we have the one which is the most positive and the one which is the most negative. So when drawing the electrochemical cell, you must have to indicate the solid bridge, and of course you know the purpose or the function of the solid bridge. It is connecting the two half cells. Then as you can see here, and again now here, after drawing this, drawing this electrochemical cell, you need to show the direction of the flow of electrons. So what you need to understand here first that the most positive half cell must be placed on the right hand side. So when you are drawing, identify the two. For example, here we have this element G, which is the most positive, and the other element N, which is the most negative. Either you indicate the most positive at the right hand side and the most negative at the left hand side. That one is a must. So when you draw this one, indicate that from this diagram, as you can see, I have the most positive, that is half cell D on the right hand side, and then we have the most negative, that is half cells of N on the left hand side. So it must be indicated like that. Then electron must flow from, as you can see, electron must flow from the most electronegative to the most electropositive. So you will be required now to indicate the flow of electrons. How do you indicate this one? You indicate the flow of electrons that after identifying the two cells, the electron must be flow from the most electronegative to the most electropositive. So you can see from here, electron must have flow from the electron cells of N to G like this one. So you might have to indicate an arrow indicating the flow of electrons. And then you must have to indicate the solid bridge. What is in that case the purpose of the solid bridge? The solid bridge, it is complete the circuit by making contact between the two solutions. It is only, you can just say it is connecting the two half cells. Then another purpose of a solid bridge is to maintain the balance of charges. So when you build an electrochemical cell, you must have to indicate a solid bridge for you to score. Make sure that the most electronegative is placed at the left hand side and the most electropositive is placed at the right hand side. Then when indicating the flow of electron, it must be from the most electronegative to the most electropositive. Then we have the cell notation or the cell representation. Once you will be required now to draw or write the cell notation, write the cell convention, or write the cell notation of the two half cells we have identified. In our case here, we have identified the two half cells, that is N and G, and therefore you need to represent this one on the cell diagram. How do you represent this one here? So one thing you need to understand when writing the cell notation, a metal must be on the higher in the reactivity series. That metal must be on the higher in the reactivity series. That's one thing that you must have to know. And then it must be drawn first in the right hand side. So you must have to draw a metal like this one here. You have identified this one here must be the high in the reactivity series, and then it must be drawn first. So you will have a metal followed by the solution. It's a metal followed by a solution. So this one here is metal N. So this one here, it is just metal N, and this one is just the solution of. We have this one as the solution of N. So it must be identified like this one, that it must be on high in the reactivity series. But now the other thing that you have to do is that if you want to draw the half cells, first of all, identify a metal and a solution. Then after a solid bridge, then you will have a solution, and then you will have a metal. Then we have there is a double stroke, a single stroke here. The single stroke, it just means the phase boundary between a metal and the solution. Then we have a double stroke here, represented here. This one represents the solid bridge, which completes the circuit or allows electrons to flow from one half cell to another cell. So when you draw and when you present a cell notation, identify the most negative and the most positive. In that case now, the most negative must be drawn on the left hand side, as you can see here. So the most negative, you have to start with it first on this left hand side. Then you finish with the most positive. So you must have to indicate like that. So don't just start with G, because G is the most positive, and then end with N. N is the most electronegative. That means now you will not score. For you to get this one, start by the most electronegative cell, separate by the double stroke indicating the solid bridge. Then on the right hand side, finish with the most electropositive. That's how you can represent the cell, limitation. Now, what are the reference electrodes? Sometimes you will be required now identify the reference electrode. Or, for example, here you might be given this one here, which has a potential difference of 0, 0. What is K likely to be? That's how you will be getting such kind of a question. What is K likely to be? So to identify the reference electrode, you need to understand that two things. One, it must have the electrode potential of 0.00. So the standard electrode potential of any reference element, it must be 0.00. Then another very important thing, when you check on the cell, if the state symbol here is given as a gas, then that element is likely to be hydrogen. So you check here, if you have been given a state symbol here as a gas, then this element, which is a reference element, which has a potential difference of 0, 0, must be hydrogen. But when indicated as a solid now, the state symbol on this side is a solid now, then that element is likely to be copper. So understand that one very well. So it is a gas, it is hydrogen when it is a gas, and if it is a metal, if it is indicated in a solid state, then that element it must be copper. That is how you can identify the reference elements here. What are they? It must be hydrogen if it is a gas, it must be copper if it is a metal, and then it must have a potential a standard potential difference of 0.00. Then the EMF of the cell is negative. If you calculate now the EMF of the cell is negative, that is, or you can get the EMF of the cell is positive, then it means that if it is a negative, it means that the reaction will not occur. It means that now, for example, if now for example, we have now the solution of J, the solution of N, can be stored in a containment of N, for example. In that situation now, you need to calculate the EMF of that cell. If you get the EMF value is negative, it means that the reaction will not occur. That means a solution of N can be stored in a container made up of N. But if you calculate the EMF of the cell and you get that it is positive, it means the reaction will occur. That means a solution of N will not be stored in a container made of M. So in such a case now, how do you calculate the EMF of the cell? For example now, suppose we have cells of N and then we have M. How would you calculate the EMF of the cell? Using this number, right? The EMF of the cell is given by the electrostatic potential on the right hand side minus the electrode potential of the left hand side. For example, we are comparing cells of N and M. So we can have it here. This M it is on the right hand side, and then we have N is on the left hand side from here, as you can see on the screen. So this one is on the right hand side, and this one is on the left hand side. So if you can use that one, that the EMF of these two cells, it must be the electrode standard potential of the right hand side, that is negative 0.44. Then you subtract the electrode standard potential on the left hand side, which is negative 2.92. As you can see from there, it will give us a positive 2.48. The positive means that the reaction will occur. It means now a solution of N will not be stored in a container made of member of N. So when using this numbering, that is how you can apply this formula. But those people who are the left-handed people, this question normally they score it wrong. Because their left-hand side will be on the other side, and the right-hand side will be on the other side. So if you are the left-handed person and you want to use a number line, after indicating this one, make sure that you turn your book upside down. That's when you identify where you will have the right-hand side, where you will have the left hand side. Otherwise, if you use it like that, if you don't use it carefully and you are a left-handed person, then you will get this one wrong. The strongest reducing or that element which has the least tendency to gain electrons. So we have the strongest reducing or the cells which has the least tendency to gain an electron. It cannot be displaced from the solution of it is solved by any other method. For instance now, if you are required to identify half cells which cannot be displaced from the solution of it is solved by any other method here. Check that element or check that half cells which has the least tendency of gaining electron. Or in that case, you say the strongest reducing agent. So the strongest reducing agent or that half cell which has the least tendency of gaining an electron, it is the one which cannot be displaced from it is solved by any other method. For example, here you can identify that one as half cells of N in that case. So if you take this one N, because N it is the least, this one it has the least tendency of gaining electrons, or you can say that this one it is the strongest reducing agent, therefore it cannot be displaced. Suppose now a solution containing J, a solution containing J ions cannot be stored in a container made up of M. Then you are required to explain why a solution containing J ions cannot be stored in a container made up of M. In such a situation, what are you supposed to do? You need to calculate the EMF of the two half cells. In that case, if you get the EMF of the cell is just positive, it means the reaction will take place. That means now the solution of J ions cannot be stored in a container made of M. But if you calculate and you get the EM of the cell is negative, it means that the reaction will not take place. Then the solution of J can be stored in a container made up of M. In that case, now you need to use a number line. You use that number line. Then the E of the cell is the standard electrons in the right hand side. The right hand side now we have J and M. So if we have J and M here, so J is at the left hand side and then M is on the left hand side. So you take positive 0.52, you subtract negative 0.44. What will you have? That one will give us positive 0.96. It is this one here, it is positive. Positive, it means that the reaction will take place. It means that the reaction will just take place, and therefore M is a stronger reducing agent than that of J. And that means now the solution of J cannot be stored in a container made of M. Make sure you have to calculate the EMF of the cell. The value here is very important. It will tell us whether the reaction will take place or the reaction is not taking place. Use this formula or you can use the oxidation and reduction. But I'm giving you a question if you are using this one and you are left-handed person, then you must prefer K. For instance, now you must have to turn your book upside down, and then that is how you can score this one. Otherwise, you might get it wrong. Then there is a situation where you are required now to identify the two elements that will give the least EMF of the cell. What are you supposed to do in that case now? You arrange the half cells in the ascending order. Arrange the half cells in the ascending order. Then you pick the two that gives the least positive. That is how you can identify the two half cells that when you combine, they will give you the lowest EMF of the cell. It is not the opposite of the case where we are saying now we combine the most positive and the most negative. If you use that principle, you can't get. In that case now, you need to arrange the half cells in ascending order. Then you pick the two that gives the lowest positive. When you combine, that one will give the least, the lowest EMF of the cell. In our case here now we have element J and G. When you combine it, they will give the lowest EMF of the cell. That is a simple summary of the electrochemistry, and that is an electrochemical cell. Keep on following me. I will be uploading part 2 on this electrochemical cell. Don't forget to subscribe my channel, watch and share. Thank you.